So here you can see properly that this is the structure of carbon dioxide, where the central carbon is connected with two oxygen atoms by double bonds. Here it is a resonance structure another structure of carbon dioxide, where the double bonded oxygen atom, this lone pair has been bonded or has been contributed here as a bond. That's why there is a triple bond here, and this bond has been opened up. That's why there is a single bond here, single bond. And since it has opened up towards the oxygen side, that's why a negative charge appears on oxygen atom, and a positive charge appears on this oxygen atom, because this oxygen has donated the lone pair in the bond. Okay, so this is another structure of carbon dioxide. Now we will be discussing about silicon dioxide, SiO2. So it is a three-dimensional network solid where each silicon is surrounded by 4 oxygen atoms tetrahedrally. This is the structure you can see here. Each of silicon atoms is tetrahedrally surrounded by 4 oxygen atoms. Okay, and this SiO2 can react with NaOH, or can be attacked with NaOH or HF to give the corresponding product. When it is attacked with NaOH, it gives Na2SiO3 and water, and when it is attacked with HF, it gives Si4 and water. Now let's move on to the next one, that is called silicon. So it is very important. This type of materials of silicon is very important. These are mainly organosilicon polymers. These are polymeric compounds which are formed by organic materials and silicon, fusion of organic materials and silicon, and ultimately they are polymeric compounds. And they have the types of compounds formed like CH3SiCl3, CH3 2SiCl2, CH3 3SiCl. Okay, Me is methyl, means CH3, and here you can see there is a bond that has been formed between CH3 carbon and silicon. That's why carbon is termed as organic element. So that's why organosilicon bondage, and they form polymeric compound. That's why the term organosilicon polymers of the type these ones. How are they prepared? They are prepared by this way. First of all, methyl chloride is allowed to react with silicon, and it is heated up to give CH3 2SiCl2, and then it is hydrolyzed by water, and the 2 chlorine atom will be replaced by 2 OH of water, and it will form CH3 2SiOH2. Here you can see CH3 2SiOH2. 3 units I have taken. 3 units of this molecule I have taken. Now, if this will undergo, these 3 molecules will undergo condensation polymerization. That means water molecules will be eliminated here in this way. OH and H will be gone. Here also OH and H will be gone. Okay, so what we will be left with? We will be left with oxygen, SiCH3CH3, and in the middle of these 2 silicon atoms there will be only 1 oxygen atom, and because the water molecule has been eliminated from this 2 OH group, so only 1 oxygen atom will be left, that is this, and again SiCH3CH3 oxygen, SiCH3CH3 oxygen, and this part will be continued to form the long chain compound, that means polymeric compound. That's why this part is termed as whole N. N could be any value. Okay, generally N value is very high here, because this chain will be continued, and the value of N is very high, and that's why silicons are polymeric compound. Okay, now let's move on to the next compound, silicates. These are the tetrahedral SiO4 2- units. You can see here tetrahedral SiO4 2- units. Sorry, it will be SiO4 4-. So where silicon is attached to 4 oxygen atoms in fashion, and these silicates compounds are often found in the form of mica, in the form of zeolites, etc. This is the common structure of silicates. Okay. Now, question you may expect from zeolites, because it is one of the most important topic. What is zeolite? When in the silicate structure, or silica crystals, when some of the silicon atoms will be replaced by aluminium atom, then silicates will be termed as aluminosilicates. Aluminosilicates is a negatively charged anion because it is also negative, SiO4 4 minus. So aluminosilicate that will be formed after the successful replacement of some silicon atoms from the crystal of silica by aluminium will be called as zeolites. Okay. Now this aluminosilicate anion will be combined with cations like sodium plus, potassium plus, etc. And these type of compounds after aluminium atoms replace the silicon atoms from silica crystal, and cations sodium plus or potassium plus are present in the crystal, then the overall compound are called zeolites. One important example of zeolite is ZSM5, which is used mainly in petrochemical industry to convert alcohols into gasoline. So these are the most important topics of P block elements. Hope you have understood all the topics. See you in the next class. Thank you.